Hey guys, what's up? Today we'll be trying to fix a Samsung TV, LED TV that has no power. So now it's already plugged in. It's plugged in, and we can't see any indicators here or standby light. It should be here, a red one, and it's completely dead set. So in this video, I'll try to show you how to fix TVs or Samsung TVs with dead set problem, and also I'll show you how to fix power supplies, tips on how to fix power supplies. It's the UN50EH. So guys, this is the power supply here, and this video will focus on this one, and the other thing there, the other board there, that's the main board, and the take-on board is right here. So it's a power supply. You can tell if it's a power supply if it's connected directly to the power cord, right? And yeah, first thing first, if you have a bad power supply, if you have a multimeter, you can measure it, volts, DC, measure the output of the power supply. So in this case, the output is right here, this one here, and let's see what are the voltages. So let's see. Let's put this this one, our black lid, to the ground, anywhere here in the frame, or right here in the screw. Yeah. So let's measure it. And this one here, it says, let me zoom it, or maybe not, just okay. So this one here, it says 13 volts here. So there's nothing, there's no 13 volts. This one's 13 volts, and this one here is 5 volts. It says 5 volts. Still got nothing. 5 volts here. So there's nothing in the output. Usually the power supply has labels here. You can tell what voltages you're expected to see when you measure it here. But in this case, there's no mode. There are no voltages coming out from this one here. Yeah, see these markings here. This 13 volts, 13 volts, 5 volts, 5 volts, yeah, and so on. So when I test it, there's really nothing coming from it. So next time, next thing we can do is, let's check the input of the power supply. Okay, so next thing we can do is, let's check the input of the power supply. So the input, obviously it should be coming from here. So now input is another type of current. It's gonna be alternating current. So do it in the AC mode here. One and now let's check what voltages we can find. So be careful guys that the DC side or cold side, and there's also a hot side on the AC. So hot side is a bit of high voltage in this case, because we have here 120 volts coming in. So we will expect around 200 or 300 voltage, 300 volts around here in the hot side. So be careful with that. And also the ground, it has different ground than the ground from the cold side or the DC side. So just be careful. And also guys, regarding power supply, if the power supply is cheap, it's not very expensive, so no need to fix it. But if it's worth it to fix it, because some TVs or some appliances or consumer electronics has expensive boards, so it will be worth it to fix the power supply. So you can do the component level fix or repair, component level repair. So in this case, I'm just showing you how to do it. So let's dive in. So first thing first, well, it's easy to check the, if you have, what I'm doing is most of sometimes, or you can do it also like this. You plug the just to see if there's voltage in here in the fuse. You can plug this in, but it's not really the most proper one, but you can do it also. So you have to see if there's voltage here. So yeah, there's voltage coming here up to the fuse, right? So what it says is that your cord is okay, right? Your cord is okay. So next is that we can check if there's voltage coming from this one that goes into the fuse, into this chokes right here. I mean, it's not choke, it could be a filter, the filter for the AC current, and goes to this thermistor here and goes to this bridge diode here, and so on. So what we can do, since we have access to this bridge diode here, we can access it like easily. So it's best to do, what's best to do is you can we can measure the AC voltage coming here. So bridge diodes always come with AC pins in the middle. So if you want to make it safer, you have to cover it with
insulation up to this point here, so that only those ones here are like only up to this side is the only thing that you can see. You should cover it with insulator up to here, from here up to here, like that, so that it's safer if you want it safer. Because sometimes if you measure the lids here, you might connect, yeah, you might short it. So it's safer if you do cover it with insulator. Like you can use heat shrink. You can heat shrink it here, see, so that only this one here, only this side here, this part here shows. Okay, only this side. So now let's measure the AC here. Oops. So yeah, it seems that the is let's measure it. So yeah, it seems that there's no AC that come here on the pins. So there must be an open circuit from here up to here. It could be the fuse, mostly it's the fuse, and the fuse is open because of problem around the board. It could be, but sometimes it could be just the fuse. But mostly if the fuse goes bad, there should be a problem somewhere, like a shorted component. So next thing you can do is because there's no AC present here, so we can check this fuse. There's thermistor, this varistor here. The jokes they don't these filters here, they don't usually go bad. And this one here, capacitors, yeah, they don't usually go bad. Sometimes varistor, yeah, varistor, when there's a surge, power surge, it's gonna short, and then it's gonna blow the fuse. That's to protect the TV from so much electricity coming in from the grid. So this one also, it could go bad, but mostly not. It's the thermistor. So yeah, let's check the fuse. Let's unplug first. Let's measure first this one, the filter. If there's a, let's switch to DC volts, and let's measure first if there's a voltage around here, just to check. So there's nothing, it's 0. And also on the positive output of the bridge, see, so there's nothing. So by the way, this one and the bridge diode and the capacitor, they're in parallel, the positive and negative, so they're in parallel with each other. So next thing to do is unplug the cord, and since there's no voltages around here anymore, so we can just measure the continuity of the fuse. So let's see. So yeah, there's nothing. It should, yeah, so there's nothing here. So since the fuse is blown, there's gonna be a either we have to change just the fuse, or we have to change some parts around here. So by the way, the fuse is ceramic type, and it's a 5 ampere. So if you see, so this fuse, we can't tell if it's really totally blown or it's just opened itself up. So we can't tell if there's really a bad short in the circuit from this fuse. If you have a glass fuse, you can tell if the problem is really bad by looking at it. So I'll show you. So see this type of fuse, right? As you can see, it's blown and it became dark. Yeah, it became dark. That's because there's a short in the circuit, and it's a good indication that you might have to troubleshoot it very meticulously, so that you're gonna be pulling out all the shorted ones, so that it will not blow again, or it will not damage other components because of the short. So this is the fuse that came from the board, and we can tell if there's really a bad problem. So don't in this case, don't just put another fuse. You have to troubleshoot it, look for shorts. Okay, so next thing to do is let's remove the board and test it all possible components that went bad. So what's next? Okay, so now that we have the board here to troubleshoot, without the fuse already. So by the way, this is a filter capacitor. This is a filter, or it's just a yeah, I really think it's just a filter. This also a filter or a choke, so these things don't usually go bad. So these are some capacitors here, capacitor here. So
So bridge diode, MOSFET or transistor. So yeah, and the SMPS main transformer for this board. It's a transformer. This one also transformer. I think it's for the backlight. And yeah, some capacitors here, some small diodes here, optocouplers. This one I think it's a diode or a MOSFET, something like that. So yeah, that's mostly the components of the power supply. And also we can have some controllers here, controller IC. Yeah, here, this is for the main the hot circuit. It's the controller for the MOSFET. Or here, MOSFET is, where's the MOSFET? Yeah, here, it's around here. And yeah, this one here, it's a controller for the backlight. So we'll right now, because the problem is there's no power in the input side, right? The hot side. So we'll focus on this side. So it's here. It's right here, not here. So first thing you should do is look for shorts. It's gonna look for shorts now. So, oh, first thing we got is shorted. So it's the bridge. It is the bridge diode here, the plus and the minus. Well, it's not totally short, but totally short is like, in my meter it's like 0.000, but this one here is like 0.0067. So it's zero, but it still has some readings left. So it could be that the bridge diode, it can blow the fuse up. It can it can do it. And let's check for other components that are really we'll look for the shorted pins that are very near to zero, like 0.000 or something. So in this case, you have to do you have to find for the very obvious one that goes bad, like big semiconductors. Yeah, they usually go shorted, like these diodes here. Semiconductors, check for all semiconductors first. So this one, it's good. Short or leaky ones, yeah, you have to check it. I think this one's good. And you can also check this, the thermistor, but this one, it's normally reading like that because it's a thermistor, it's a resistor, and it's just changed its value when there's current flowing through it, with regards to the temperature. So it's just gonna, with regards to the temperature, the current is gonna change its value. So mostly if it goes bad, it just goes open, right? Or the resistor is not, the resistance is not very close to the intended resistance of it with regards to the current flowing to it. So you can also check the varistor. This is the varistor here. Yeah, it's like two diodes. It's like two diodes meeting each other. Facing each other. It's two diodes. There's a power surge. It's gonna short. So when it becomes shorted, it's gonna blow the fuse, because it's like parallel to the fuse, right? It's parallel to the fuse. Yeah, one of its one of its pin is parallel to the it's connected to the fuse, and the other one is to the other line, yeah, this one here. Okay, so you can also check these ones here, but they don't usually go bad. So most of the time it's the semiconductors that go bad, and when they go bad, it's gonna open up some resistors, or gonna cause some leaky problems on capacitors, or also some capacitors will go short. So most of the time those veterans, when when semiconductor got shorted and there's a capacitor close to it, so usually they also change the capacitor, because that's a good thing to do for prevention that it might go bad again. So right now let's check this one here. It's a MOSFET. It's the one that's in this circuit. It's the one that is what you call that, making the transformer function. So because yeah, it's gonna make some on and off switches, on off on off on and off switching, which will make the voltage go up and down, and it will create something like what do you call that, alternating current, something like that, and it goes to the transformer. So that's the reason why the transformer will emit some electromagnetic what do you call that, electromagnetic current, or yeah, voltage or something like that, and then it goes to the secondary side, right? Because transformers don't function on DC volts, right? It has to deal with AC, or alternating current. So this one is responsible for that. So mostly it goes bad if there's something happen with the power supply or the fuse. So let's check this, and here's the pin for that. So it also has a shorted reading here. So since there are capacitors here and a resistor hiding in here, we can check it, and there's also some semiconductors here, but I think it's for the backlight, but let's check it anyway. So these ones I think are good. They're not shorted. And it's also this one. It's I think it's a diode. It's a Schottky diode. We can also check for shorts in here. So this one is good, I think. And this, the capacitors, these blue ones, we can check them. So these readings don't say that capacitors are good. They could be bad or leaky. Yeah, this one is shorted also, or maybe it's just parallel to these pins from the MOSFET. That's why it's reading right here. But mostly capacitors, you can't just tell if it's good or bad by just testing it from the board. Even when you test it with a even if you test it with a capacitor tester, you can't really be sure that it's in good working condition. It could go bad when there's voltage or current flowing through it. So yeah, what what we can do now is, yeah, I'll try to remove this, let's try to remove this one first, the main switching, the switching transistor, or yeah, it could be yeah, it's either a MOSFET or a Darlington, or yeah, we can try it. Mostly it's the problem. And so some people will just hang the pins first before removing it all. But right now, I'll just remove it anyway. Or yeah, because it's really hard to just hang it up. So the pin is still connected to the PCB. It might be easier to just pull it out. Then let's so now we just pull it out, and then let's test it. Oops. So yeah, this reading is, indicates that it's short, but not totally short, but it's like, yeah, this is a bad one. So like now that we have taken, like, maybe it could be causing the shorted reading from the bridge diode, right? Because earlier it reads something like 0.0067, and now, yeah, as we measure it, it's gone. It's now 0.8906. Earlier it was 0.0067. So what we can do is also check some of the components here. These components here are, so yeah, these components here, they are essential to the MOSFET. Yeah, these components here are connected to the driver,
and it could be shorted. Some of them could be shorted or open, and because it's connected to the driver, it should be it's connected from driver and in between the MOSFET. So this one's here, it's connected between the MOSFET and the driver. So if something goes bad here, it's gonna blow your MOSFET again. So let's check it for short or open. This one here, it's what's that? So is it a 22 ohms, 68 ohms, and the smaller ones are I can tell the small one. So let's check it with a resistance here. 22. Yeah, that's 22. Good. And this one here, 68. Yeah, 68. This one here should be ready. It's 9. So it should be a 10K. Let's see if it's 103. This one, yeah, that's a 103, right? So that's good. That's 10K. And let's check the transistors here. Transistor looks good. So this short, because it's connected, these two pins, I think, yeah, they are connected here. This pin and this pin, they're connected. They're in just same line. So this should normally read like that, 0.000. Okay, and this one here, same. And let's check the 0.904. 0.904. So 0.904, it could be, that reading could be because of these two resistors here. See? Because they are in line with this. See, if I read from this side of resistor here and this one here, so it could be, it could be that the transistor is bad, but we cannot pull it out and test it because it's so yeah, because this one is, we can't just pull it out and test it because it's SMD, right? If you will pull it out, it might go bad. So let's leave it for now like that. And I don't think that this transistor here is not bad because it just reads short from this pin here to there, and not short, it's just beeps. It's like, but I think it's not really short. So what we can do next is, there's a capacitor here, right? Capacitor here, resistor here. So let's measure these things. And it's also, yeah, as I've said, it's safer to just replace these capacitors. It could be bad.
And also this resistor here, it's like the markings are black, gray, black, gray, black, gold, black, gray, black, gold. So let's measure it. This is the one. Black, gray, black, gold. Bad boy rape our young bad I gave. So 8, so 1 6 1 8 0. Yeah, I'm expecting around 0.18, but yeah, it says 0.16 here, so it's okay. Yeah, that's okay. And also let's measure what's the resistance of the transistor's pins, because it reads 0.09 on the diode test. Well, let's see what it reads here. So it's like 90 ohms. 90 ohms. Okay. Well, if you pull it up, the transistor, and it still reads 90 ohms, so the transistor must be bad. So next thing to do is let's just put it's just because it might be hard to find these capacitors, so for now in this video, but I recommend replacing this capacitor here, the blue ones. And since it might take a bit longer to find these capacitors from my spare parts, so I'll just replace the transistor for now and then see if it's working. So that's how you troubleshoot the circuit, right? And there's more options or more things to do to make, but some components, they just can't be tested in the circuit or while it's turned off. They will show its problems when it's on, so you can't really tell if they are bad. So let's try to replace it now. And since I have parts for this, this is equivalent to this. I mean, they're the same, they're identical. And I'll just replace it now. So since it is bent, middle one will also bend this. So the way you bend it is you clip it here, and then let's bend it. Make sure to clip it so that when you bend this, the connection here between the plastic and the metal is not gonna break. So spin it. Okay, so that's the way it looks now, bended. And then let's clip this one here, just this one in the middle. Let's clip it, and then bend it again. So that's how you do it. Okay, and let's see if it fits here. Let's simulate it. And this, if it fits here, it's gonna fit from the top. So it fits right in the bottom, right? So it should fit from the top. And also we have to put the thermal paste, heat transfer paste. Well, some designs, if it's not very hot, if the transistor don't get really hot, there's no need for this. This type of case in some circuits they don't put it on the heatsink. Well, it just depends on the design. So let's put it here. So wiggle it, and but not too much. So you might break down. You might break it. Yeah. So see if it's going through the hole. So now it's inside. I mean it went through, but yeah, but there's something blocking its way down. It's this. It's blocking it. So the designers put this sealant here so that the pins of those components, they don't go shorted by dust or some debris that accumulate in the long run. So that's a preventive measure for them. So let's put it down. Let's put it back. Maybe it's gonna fit right in now. Yep. Yep. And then first thing is put the screws first before soldering. I mean just the screw, just only one. Okay. So by the way guys, these ones here, they're just choked. They're like ferret beads, and they usually read short. They're okay. That's how they are. This one here, this one here, this one here, and one here. Okay. I forgot we did not measure the capacitors for some short. You can also measure it for some short, but as I've seen here, there's nothing that's bad. I see. So also, to make sure, you can also check these components here, these components around the controller, because if something goes bad here, it's gonna make the switching not acceptable for the MOSFET, and then the MOSFET goes bad. But it's yeah, you can check it like the resistance check on the resistors and diode test on the transistors, just like that. You can also do that, but for now let's just do it on here and see if it solves the problem. And Then put some intervals. Don't just solder them all. Don't solder all the pins at once. Put some interval because it's gonna make the junction of the transistor so hot, so you might break the internal circuit of it. This one here, the last pin. Okay, it's now soldered back. And yeah, next thing to do is cut the yeah, let's cut this. Make sure to cut it so that it won't get short. Just leave a very small amount of the pin here. It must not be very tall. Next thing, yeah, I found here a fuse from another Samsung TV. And you can just put it here, but for safety measures, guys, if you have something like, for example, this thing needs 5 ampere, right? 5 ampere. So to make it safer, usually if the problem is a short or a surge, something like that, yeah, you can put a fuse that is lower than this, like 80% lower than the 5 ampere. So it's gonna be 4 amperes. Yeah, example 4 ampere. So why should you put that 4 ampere here? Just to the reason is just to see if there's other problem that exists, so that what I'm trying to say is that if you put here 4 ampere and because there's still a problem here, right? For example, there's still a problem here, a short one, so the fuse is gonna blow very quick, right? Because it's only 4 ampere. So that signifies if you see that the fuse blows the 4 ampere, so there could be another problem here that you messed out. So you have to recheck it again, check all the shorted ones or leaky ones, because 4 ampere, it should not 80% fuse, it should not blow like right away. Maybe it will blow for some in the future. I mean, yeah, if quite in the long run it's gonna blow. But if you just use it for testing, like it won't blow any moment from the, because it's not too low. It's not like 3 ampere, it's just 80% of the 5 ampere. So it's still gonna work. So 4 ampere, you put 80% fuse just for testing purposes, so that if there's short here, it's not gonna make other damage to the other components, right? Because the fuse has already blown, right? And also what you can do is, for this one here, you can put a bulb here. You can put a bulb here and make this as a fuse. You know what I mean? So you can make this as a fuse, like you put it here instead, like that. You put some alligator clips here and then put it here. So the bulb is now in series with the circuit. You put some 100 watts to 150 watts bulb, so that when there's still a short here, the short will just be consumed, or the current will just be consumed by the bulb, so it won't blow things up here, right? So what would it do is that let me show you here. So for example, this is your circuit, right? Circuit here, there's a circuit, it's your power board, the board, and so the fuse, it's the fuse, right? And so this is the line. So yeah, this is the line, and yeah, just connect it. This is your circuit, so this is your fuse. So instead of putting a fuse here, you can just put a bulb in between. You can just put the bulb. So what is it should be the bulb's schematic, maybe like that. I don't, that's a motor. Yeah, I think so, something like that, right? Yeah, I think it's a bulb. Yeah, I think that's the bulb. So what happens now is that if the board gets, if there's a short here, so it's like a conductive or capacitive resistance, right? Or let's just say a resistance here. There's a resistance here, so it's not shorted, right? Circuit is not shorted. But if it goes shorted, like that, so, or maybe if there's a here, and then there's another here, and then like that, something like that, capacitors. So if there's a let's just say like that. So if there's a let's just say like that, a circuit, and if there's a short somewhere here, but if maybe your diode becomes shorted, for example, there's a diode here, and if even if it becomes shorted like that, right? So it could blow the fuse if you put the fuse here, and also it could make this guys open. You can open this, or you can short this capacitor. You can also short this or open it. Okay? I mean, this short could cause those problems. It could break these components, right? Because there's a short here, and because it's not the because the current is not directed to another another path, right? Because you only use the you only use the 5 ampere fuse, right? Because you use the, for example, 5 ampere, yeah. So before it blows up, it could have already shorted here and damaged those parts here, right? But if you replace it with 4 ampere, when it's shorted, for example, it's short, For example, there's a short in the circuit like this. This 4 ampere is gonna blow so quick in milliseconds, or just quicker, that it can't damage, that the current flowing through it will be cut, and it won't damage those some other parts anymore. And also, if you use the bulb, yeah, I forgot what's the schematic of the bulb. It's just, see, it's like this, like, so yeah. So yeah, if this bulb is 100 watts then. So if there's short here, there's a short here, the bulb will consume all those what do you call that, current flowing from this side here up to there, because it will look like this. There's a short, right? There's a circuit here, so basically it will just look like this. This line here is gonna poof like that, right? And so because of that, it's gonna consume all the current, so it can prevent these components here from being broken. See, that's how the bulb works. So that's a preventive measure how to fix power supply, especially when your power supply is expensive one. You better do precautions on fixing it. Okay, so let's see, where is it? I hope you get what I'm trying to say. So now that we have it all, we had soldered the MOSFET, and I found a fuse. So now we are ready to put it back to the TV and test. Okay. So yeah, now guys, so now right here, put it back and see what happens. Oh. So now it's time to test it. And see. Okay. Got this. Oh, see, it now has sound, man, and the backlight just got on, so it's a good indication that the problem is solved. And let's check for first thing is to do after it is you're gonna test the stability of the voltages. So here, check the 13. Yeah, it's stable, and 5 volts. Yep, it's stable. And what more? Yeah, I think these are just the A 5 volts. Another 5 volts here. Yeah, it's stable. So yeah, that's what you're gonna expect if the power supply is good. Output voltages are stable, and also you can also check if the power supply is okay by doing the by testing the temperature of it. But since we don't have that stuff for now, the thermal stuff, the thermometer, so the IR thermometer, so we can't do it right now. What I'm doing is just after this I'll touch the MOSFET and other components surrounding it for high temperature. If it's so hot, then it could be that there's still another problem around. So let's see if the TV really turns on. The TV is really working. Let's see. So yeah, now it's working now. So you can also see the standby light around here. If it's off, see, if I'll turn it off. Yeah, standby light here. So yeah, I think we resolved it, and we got it working. Yeah, see. And what I'll do is, after turning it on for 5 minutes, or in case of this video, I'll check the temperature of the component that I just put in. So I'll touch the so be sure to unplug it first and then touch the heatsink first, and then the component. So now I'm touching the MOSFET here. If it gets so hot, and some other component here, if it gets so hot, just be careful not to touch the pins of the capacitor or the body of this main capacitor. It still has some voltage in it. Okay, just don't touch the pins, only the metal, no, only the case of the semiconductors, but not the case of this capacitor. Okay, because it has very high voltage in it, stored in it. So I think I've solved the problem now. So what I'll do is just make it turn on for hours and see what's happening, or see what happens if it really has no problem at all. So I'm gonna do born-in test on this before disposing before sealing it or using it as my TV. Okay, so that's it, guys. I hope you learn from this video, and see you on the next one. Okay, bye.